My PPT is visible.
Yes, ma'am.
Someone has not muted the mic.
Participants may mute their mic only when they are interacting with the resource person. Unmuted.
नाही ना ग आज घ्यायचं आता ताईने आणखी
So may I start, sir?
Yes, please. Yes.
Thank you. Good afternoon, everyone. I think my presentation is visible. So my talk for today's session is going to be cryptography and information security. As sir introduced, I'm Buna from SSN College of Engineering. I have been taking this. I'm very much interested in cryptography and information security, and handling this kind of course for several years now. And so this is going to be my agenda. Let me introduce the concepts of cryptography and information security, and we'll be seeing what is the actual model needed for network security and what are the two different kinds of encryption, that is symmetric and asymmetric, or otherwise public key cryptographic techniques. So this is what I'm going to focus in today's session. Since this is going to be the introduction, let me take you through the preliminary technologies and techniques that you may need in order to understand the forthcoming sessions in your FDP. Um, in today's world, we are generating too much of data. Every minute, every second of our life, we have been generating data. So such data are stored in the storage devices or in our computers, and those data that we are generating need to be secured or protected. So we need some kind of mechanisms to secure our data. So we can think about like why not we post a sentry or a security outside our room so as to keep our data present in the computer safe. Yes, that was possible, and that is also possible. But what if your system is connected to internet? Okay, so that is, internet is networks of networks. Your system is connected to another network, and that is connected to another network, and these interconnected systems together form network. Okay, so when we are connected to the network, posting a security outside is no longer a viable solution. So we need some kind of automatic tools and techniques to secure our files so that no one from outside can access we can avoid unauthorized access or unauthenticated accesses, okay, over the data we have. Okay, so those data may be our personal data, our institution related data, or our industry related data, or maybe a sensitive data or a defense related data. Such data, or each and every data, requires some kind of privacy and security, which will avoid unwanted and unauthenticated accesses over it. So now we understand why we need security for our data. So uh, with that, let us see the terminologies like what is computer security, what is network security, and what is information security. So computer security is the one. It's I would say it's a generic umbrella term, kind of term that will I mean that is equivalent to the collection of tools designed to protect our data from the attackers or the hackers. Okay, that is the computer security. It's an umbrella term. It covers all the tools and the techniques that are used to protect our data. And what is network security? As I said earlier, when your system is a standalone system, I would say simple security related tools are enough to secure our data that is present in our standalone system. When you are connected to a network, you need to look into some specialized techniques and tools that can protect our data during the transmission of our data from one system to another system. So that is what the network security is about. So protecting our data during the transmission from one system to another system is the network security. So what is information security? So there comes the specific services of security like confidentiality, integrity, and availability. What is confidentiality, what is integrity, and what is availability? I will be explaining all these things in detail in the forthcoming slide. Just let us take these terms as such now: confidentiality, integrity, and availability. We are going to provide all these services in I mean, whether they are in the storage or during the processing or during the transmission. Okay, so it can only be achieved by using specialized tools and techniques or tools and mechanisms, and that need additional training, or it may require additional awareness in order to provide it. Okay, so computer security, network security, and then the information security. So these are the basic three security terminologies one need to be aware of. Okay, so there comes the three phases of security. We call that as security attack, security mechanism, and security service. So let us see what is a security attack, security mechanism, and security service. Security attack. So what is an attack or what is hacking? When we call something is attacked, when some action happens that compromises the safety and security of our information that we have stored in our system, then that action or that operation would be called as an attack. Okay, an action that compromises the basic security of the information present in a system or present or owned by a organization. Okay, so we need having known that organizations are vulnerable to all possible actions that may compromise their safety. Now we need to learn more about what type of vulnerable actions that may happen over it, what type of operations that can happen over these data or the information such that the security is compromised. So we need to learn who are what are the possible attacks that may happen. Okay, so there are two different classifications in general. One is the passive attack, another one is active attack. So what is a passive one and what is an active one? Passive one is simply observing. If there is a network, and in the network there may be n number of systems connected to each other, where there may be one system called as a server and the other systems may be called as a client that may access some services from the server. Okay, so at a point of time, there may be n number of packets. Say the information that is transmitted from one system to another system may not be transmitted as a single stream of bits of ones and zeros. According to the underlying protocol, the data may be divided into several equal sized packets, and with respect to the protocol we are following or the system is following, the protocol header allows what is the maximum capacity that can be carried by a particular packet. Okay, so n number of packets may flow from one system to another system at a point of time in a network. Okay, by simply observing the packets being transmitted from one system to another system, I would easily gather so many information like who is sending this packet to whom, or by what time this packet communication happens, what is the length of the packet, what is the header information available in the packet, and from the header information one can easily get to know who is the sender and who is the receiver of the communication. Okay, what is the actual data being transmitted in the packet? By simply observing the communication happening in the network, one can gather so many statistical information, and these information can be given to the people who are not authorized to use such kind of information. I may not be a person who can access that kind of information, like who is talking to whom, by what time the number of packets are transmitted from this system to that system, kind of information. I may not be the actual person who are eligible person to get to know all these details, but if someone gathers for me and gives it to me, and if I can make use of that particular information to attack, to make an attack, to compromise the safety of their system and their data, then that kind of attack will be the passive attack, simply eavesdropping or monitoring the communication. So I simply monitor the traffic. I can simply monitor the traffic. Can you excuse me a second? So that kind of observation will be the passive attack. So what is passive attack? You simply observe the traffic being happening in the network, and we don't do any kind of modification of the data. I simply observe what is the size and what is the length, and how many packets are transmitted, by what time it is transmitted. Such kind of information I can gather, but I'm not doing any intentional modification to the data being transmitted. So I'm a passive attacker. I'm compromising this kind of the security of the data by passing this information to someone who is unauthorized to access this information. So that is the passive attack. And active attack, not only I observe the traffic, but also I try to insert new information into the data being transmitted. I delete some information that is being transmitted, and I simply modify the message, or otherwise I can assume, I can claim that I am someone else, and I can talk to you as someone else. So that kind of modification happening to the data being transmitted, that is the active attack. So what are the possible active attacks that can happen over the data being transmitted? Masquerading. So masquerading is impersonation. What is impersonation? It means that you impersonate yourself as somebody else, you claim yourself as somebody else, you act yourself as somebody else, and you talk to the authorized person, and you communicate with them, claiming yourself as the actual sender of the communication. The receiver who is communicating with you, receiving messages from you, they think you are the actual sender of the communication. They may not know they are talking to someone who impersonates himself or herself as someone else. That kind of attack is the masquerading attack. I'm not going to masquerade myself, or simply what I can do, I can capture the communication now and I replay it tomorrow or day after tomorrow or day after the next. Okay, so that kind of attack is replaying the message. And other one is I send a message to you, someone in the middle can capture the communication and add something or delete something or insert some additional information to the message being communicated. That is the modification of the message. The last one is the denial of service. You'd have heard about DOS attack. Denial of service is, I would say, there is a server which can handle 20 requests from 20 clients at a point of time. If someone knows this kind of information about the capacity of the number of requests that can be handled by the server, what he can do, he can initiate n number of requests and submit those requests to the server. So that point of time, the server does not know these requests have all been generated by one disgruntled employee of the same institution, and in order to occupy the maximum capacity of the particular server, so that denying the service of the server to the potential other clients who may be requesting that point of time. So if this single person is made to occupy the maximum potential of the server, the other people who are making requests that point of time may not get a chance to get a service from the server. Okay, so that is the denial of service. Or otherwise, this can otherwise there is another sense related to this. As a sender, in any communication there will be a sender and a receiver. The sender, after transmitting a message, he may or she may deny that he or she sent a message to the receiver. The same way, the denial of service can also happen at the receiving end. The receiver, when receives the communication, may sometimes later point of time deny that he or she have not received the message earlier. So that is a kind of denial of service attack. Okay, so these are the two classifications of attack in general. So we are talking about the three different facets of security. One, we started with attack. We have to study what possible vulnerability is present over the data we are working with. Once we know what may be the vulnerable thing that can happen to our data, we go for thinking about how to handle the attack. By what procedure, what I would do to handle or to tackle that kind of compromising the security of the data. So what procedure I'm going to use to handle the security attack will be the security mechanism. Okay, so it's not a single mechanism, it may be combination of several mechanisms. Okay, so what is a mechanism? Some procedure, it's a procedure or set of all steps that are designed to prevent from the attack, prevent the attack from happening. If it is not prevented, if you have some procedures which does not which do not have the capability of preventing the attack at the first place, it means that the attack has happened. Assume the attack has happened, then at least you should have the capability of detecting it once it has happened. So detecting is enough? No. Once after I detect that attack has happened, I need to have procedures to recover my system from the attack and bring back the system to its normal operation. So I need to find some solution or procedure to prevent or to detect or to recover the attacks, recover from the attacks. Okay, such thing is called as a security mechanism. Okay, so one popular security mechanism is cryptographic techniques. That is what we are going to see today. And the last comes the security service. Okay, so how to do how to tackle an attack will be called as a mechanism. What to do to handle the attack will be called as a service. Okay, please understand the difference between the mechanism and then the service. What to do, if I am asking you to do something, that I would say I am asking for a service from your side. If I say this is the way you're supposed to give me that kind of functionality, then that will be the mechanism. Okay, so security service, it is that to counter the security attacks and implements the security mechanism. So there are two different kinds of there are there are several kinds of security services in specific at the outset. Mechanisms can be classified as specific security mechanisms or pervasive security mechanisms. Specific security mechanisms may be pertaining to a particular application. For email, I would go for email security applications. For HTTP or web text, displaying web text, I may be going for some other protocol that is specifically designed to protect the browser and displaying the web content. Okay, so that kind of applications that kind of services can be called as a security specific mechanisms. Okay, and there is this pervasive security mechanisms. It is, if your system has some pervasive security mechanism, it is present it provides security to every other unit of data in the system. Okay, so those are all the pervasive security mechanisms. But there are some services defined by the International Telecommunication Union Telecommunication Standardization Sector. So this is a standardization sector. Just take this a term. I think we have come across this term as ITUT. It's International Telecommunication Union, and T refers to Telecommunication Standardization Sector. So it's a kind of special interest group that works on standards. So if this union, if this sector comes out with some standard, we people who communicate from this geographical part of the world to someone who is located in the opposite in the western part of the world, then we both of these two end parties in the communication have to have a uniform platform, then only the communication will happen. Okay. And if this is required for communication, if I want my data to be transmitted from this end to the other end, to the western part of the world, in a secured form, I may, if I may go for implementing some security service or security mechanisms. If the other end is also wants to secure their data, and they prefers using some other kind of algorithm or procedure to secure their data, and the way I
हेलो
secure my data is different from the
हेलो
way
नमस्कार
they.
मनु जी, आप आए हैं कॉलेज? अच्छा अच्छा, मैं आई थी
uh,
वैसे आपसे मिलने, आप थे नहीं वहां पे, मुझे लगा लंच करने के लिए गए हैं शायद। नहीं, लंच टाइम में आई थी मुझे लगता है मैं। हाँ हाँ हाँ। अच्छा, मैंने ना आपको मेल किया था परसों भी और आज भी किया है। एक के फादर ना मुझे बहुत ही मैसेज कर रहे हैं, वी मालविका।
So, if both the end parties in the communication use two different methodologies, two different methods or procedures to secure their data, there won't be any kind of security communication cannot be received by this end and cannot be retrieved cannot retrieve the actual message from the communication. So that's where the standardization parts comes in. So the standardization sector, it comes with procedures and call them as standards. If there is some standard, I am supposed to follow the standard. So it gives me a uniform platform for both the end parties to communicate among themselves. So there are five different services available in that manner, which are generalized, which are defined by the ITUT standard, which is called by the name. Each and every standard comes with some number that uniquely identifies the standard. This is the standard that talks about, that defines about the security procedures during the communication, X.800. So it defines five different services. Let us understand one after the another: authentication, access control, data confidentiality, data integrity, and non-repudiation. So what is authentication? That is not a new term to us, right? So this particular term tells us, if I'm talking to someone, if I'm the word I'm using, talking here, is communicating with someone. I mean, I'm sending some message through my system to some other system in the network. I need to know who is at the other end. The same way, the other end should claim with whom this particular end party is communicating with. If both the end parties are able to claim the identity of the user they are communicating with, then it can be that particular service will be called as authentication. Okay, assurance that communicating end party is the one that you are claimed to be. And next one is access control. Access control is a kind of authorization. It is like, even you are an authenticated person, I'm talking to an authenticated person, that does not mean that authenticated person is allowed to access all the data in my system. He's allowed to access some portion of the data, and he's not allowed to access the rest of the portions of the data. So defining which resource can be accessed in what way, whether is it readable or modifiable, okay, or executable. If I am an authenticated person, if I can read one portion of the data and I cannot execute another portion of the data, and I cannot modify the particular part of the data, that kind of definition, someone says you can do this on this data and you cannot do this kind of operation on this data, is called as access control or authorization. Okay. And data confidentiality. So confidentiality comes in maintaining the privacy of the data. So what is the privacy? My data cannot be disclosed to someone else who is not authorized to access the data. Okay. So I'm sending you a message. You are the intended recipient to receive the message. You should not disclose that message to someone else who is who is not an intended recipient of the communication. So that way I maintain the privacy of the data. That is otherwise called as the data confidentiality. And integrity is, if I send you a message, it has to reach you in the same form. It should be reach the receiver intact. Otherwise, if something happens to the communication during the transmission of the message, the recipient of the message will not receive the message in the same form as it was sent by the sender. So the actual the desirable property here is, whatever the sender says, it has to reach the receiver in the same form as it was sent by the sender. That is called as integrity. If that does not happen, that kind of action will be called as an attack on integrity. If you are not receiving what I have sent, then it means that something happened during the communication between this send party and the receiving end party, and that is an attack on integrity. Okay. And non-repudiation, remember, we have seen a term called denial of service. The denial of service, allowing the sender or the receiver, I mean, I mean, they deny that they have done something earlier, what they have done earlier. Okay, if I am the sender, I may deny that I have not sent you the message, and the receiver, after receiving the message, it can deny that it has not received the message. That is the denial of service. Okay, that is that kind of attack, we call that as a repudiation attack. And since we are talking about services, the services is to handle the attack, right? So the name of the service that handles the attack, the repudiation attack, will be the non-repudiation attack. So these are the 5 services defined by the standardization sector: authentication, access control, confidentiality, integrity, and non-repudiation. Okay. So let us see, having seen what possible attack may happen, what may be the services one need to provide, let us see how we are going to provide the security. Okay, so what is the basic system, basic model that we are going to follow, that we need to follow to secure our data during the communication? That is why it is network security. So look at this one. There is a sender on your left hand side and a receiver on the other side. The sender wants to communicate to the receiver. If I send the message as such to the receiver, uh, any kind of attack, any kind of action that can compromise the security of the data can happen between the sender and then the receiver. So I'm going to apply some kind of transformation on the message I'm transmitting, so that now the after transformation of the message, I'm going to call that message as a transformed message, or otherwise a secured message. So what I'm going to do is, I generate the message. What I do is, I transform that message into a secured message. So this is going to be the transformation. This is going to be the transformation that is to be applied over the message. And now after the transformation, the original message will be called as secured message. Now the secured message will be sent to the other end through a channel, and that channel will be a communication channel. Okay, so when the receiver receives, it is in the form of the secured message. It is a message that is wrapped up with some additional layer, and the additional layer is for the security to protect what is inside the message. Okay, so now, but the recipient is very much interested in what is inside that communication, so it has to remove the outer layer, that is called as a security layer. So that is what happening here. The reverse transformation happens. So it unwraps the security message so as to remove the security layer over the message and takes the actual original message. Okay, so so this is the actual mode of communication between the sender and then the receiver. But someone in the middle, some who wants to introduce some confusion, who wants to compromise the safety of your data, who wants to do something to confuse the sender and then the receiver, will be called as the attacker or the hacker. What he tries to do, he goes and access this communication channel. What he gets from the communication channel, it is secured message that is what being communicated through the communications channel. So the secured transformation is not known to the opponent, the attacker. So when he receives the a secured communication, secured message, he may not able to open it and see what is inside the message. communication. So thereby we are securing the message. So this is a basic model we generally use to secure our data during the communication. So to implement this kind of model for securing the data during the transmission, we need a procedure, okay, which can be which will be applied on the data to be called as a security transformation. Okay, so I said, right, we perform a security transformation over the data. So that transformation, you need to have a procedure or an algorithm. So we need to design an algorithm that transforms the message into a secured message. And also when you look at this one, in this transmission, there is an additional information is also fed to the transformation called as a secret information, which is not related to the data that is being transmitted, but some additional information. Okay, so this information, with this with the help of this information only, the transformation that is being applied here will be operated over the message. Okay, so this particular circular symbol accepts two inputs. One is the actual message that needs to be secured before sending it to the other end, and the additional information that we are feeding it to the transformation procedure. So the additional information, what we call as a key. Hereafter we may use this particular term called as a key. So and that key, assume, so this can be easily understood by an analogy, like I'm sending a message. I wanted to be sent that particular message in in a secured form. So I put it in an envelope and put it in a box. I lock it, and the key I am locking the particular box. Now the secured, the locked box will be sent to the other end. How does the other end open the box? It needs a key. So that key which was used to lock that box was with the sender. So now, unless otherwise the sender sends the key to the other end, does the receiver open the box? No, it is not possible. In the same way, if we use an additional information to be called as a key or otherwise a secret information to apply this transformation that secures a message, the same thing needs to be shared with the recipient also, so that using the same secret information, the other end will do the reverse of the transformation that is happening here and open the actual security layer over the message and gets back the original message. So we need to generate that kind of secret information hereafter, which will be referred to as the keys. Okay, and you also look for some mechanisms to securely transmit, to share or exchange the key with the between the sender and then the receiver. Okay, and we need to design a protocol is nothing but a set of guidelines. Okay, so we need to have a protocol that performs all these three actions, the first three set of steps, what we have seen in this slide, together, and to be all these three constituents uh, made to work together and to be called as a single protocol. So this is the model of the network security. So now we come to the other step, that is cryptography. So what is cryptography? We have been seeing what is an attack, what are the possible classification of attack, and what is a service, and what is a mechanism. We have made the foundation. Now we are going to move further into cryptography. What is cryptography? What are the terms we are supposed to know before getting into the study of the transformation that is going to happen on this message to be converted into a security message. Okay, so let us start with the terminologies. The first one is plain text. So what is a plain text? I am generating a message as a sender which I want to communicate with the receiver. That original message I generate will be the plain text. Okay, and I apply some security procedure over the plain text. Now the original plain text will be converted into a secured message. The secured message will be called as a ciphertext. Okay, and the security transformation I apply on the plain text that gets converted into ciphertext will be called as a enciphering or encryption. Okay, so it means that the procedure that performs the transformation is called enciphering, or in general we use the term encryption. It is the procedure or the algorithm that is going to transform plain text into the ciphertext. Ciphertext is the one No one can understand what it is, since it may be in French and Latin, kind of non-intelligible or otherwise unintelligible words, which may not be understood by any attacker when he gets it first from the communication channel. Okay, so now this ciphertext is moving through the communication channel towards the other end. The other end receives the ciphertext, but what it is interested in, the other end is not interested in the ciphertext, but it is interested in what is inside the ciphertext, which is called as a plain text, the original message that was sent by the sender. So what it has to do, it has to perform the reverse transformation, which was called by the name, which was happened at the sender's end, called by the name encryption. Okay, so the reverse transformation of encryption that is happening at the receiving end, that converts the received ciphertext into the original plain text, will be the decryption or the deciphering. Okay, so this is called as deciphering. What is deciphering? It is the reverse transformation that is happening on the received ciphertext in order to bring back the plain text. Okay, the study of encryption and decryption is called as a cryptography. Any doubt in here? What is encryption and what is decryption? Do you want me to stop? And any doubt here until this point about what is encryption and what is decryption?
No, ma'am.
Okay. Um, so the study of encryption and decryption is the cryptography, and the procedures we use to transform to perform the encryption or to perform the decryption will be otherwise cipher or cryptographic system. Okay, and when I say I do cryptographic system, I thereby securing my data plain text into ciphertext, I would say it is a protective of the operation of the transmission. Okay, whenever there is some set of people to do the constructive part of operation, obviously there comes some people to do the destructive part of their operation to bring down the constructiveness. Okay, so that kind of destructive part of operation will be called as a cryptanalysis. It means that someone who is not aware of what is the algorithm, what is the key being used, what is the plain text that is being secured, and what type of algorithm is used, without knowing all these information, if someone tries to break the cipher text in order to bring the plain text out of it, will be the person called crypt analyzer, crypt analyst. And the action he does in order to bring the plain text out of the cipher text will be called as a crypt analysis. It means that he's not aware of what is the key being used and what is the plain text being secured. Who is aware the key used? Only the sender and the receiver are the two entity in the communication who are aware of what is the message being sent and received, and what is the additional information that helps us to do the encryption or the decryption, which is called as a key. Without the knowledge of the key, anyone who tries to tap the communication and break down the communication to get the original text will be a cryptanalyst, and the action he does will be the crypt analysis. Okay, the techniques used for deciphering the message without having any knowledge of the enciphering techniques. Okay, and the study of cryptography and cryptanalysis together called as cryptology. The science of both cryptography and cryptanalysis will be the both the constructive part and the destructive part will be the cryptology. Okay, so having seen this, let us get into the actual classification of the encryption. Now we learn what is an encryption. It is a procedure that is going to accept a plain text message and apply some security transformation over it with the help of the key, and it is going to generate the cipher text. That is called as a encryption. So the encryption, we are going to see the classification of the encryption before getting into the actual details of symmetric key and what is asymmetric key encryption. This symmetric key I mean, the classification of encryption is of three types. Okay, so we know where does the encryption and where does the decryption. Can anyone help me in answering which end party performs the encryption, which end party performs the decryption? There are two end parties. One is the sender, another one is the receiver. Who is supposed to do the encryption and who is supposed to do the decryption? Yes, the sender does the encryption. The reverse of encryption is the decryption that happens at the opposite side. That is the receiver side. Okay, thank you. Um, Yes, people are answering. So there are three different types of encryptions, three different classifications in the outset. Let us see what are the classification. So the type of transformation we have been talking about right from the beginning, that secures our message. What is the intention here? Somehow secure a message before sending it to the other end, or otherwise someone in the middle will capture the message and release it to some unintended recipient who may not be authorized or authenticated to use the communication. Okay, so what is the measure I have taken? I am going to apply some operation, call it as an encryption. What does it use? It accepts two inputs. One is the actual message that is to be secured before it is sent to the other end, and some additional information that helps the encryption to get operated upon the actual message, called as a key. Okay, and within this, we are talking about that the security transformation, right? What type of security transformation we are going to do? Whether I'm going to take the input, replace it with another input, substitute that with another input, and generate a cipher text, calling it as a substitution cipher. What type of operation I'm going to perform inside the security transformation? Whether I'm going to replace a few letters of the input and replace it with letters of the cipher text, then that will be a substitution technique. Or otherwise, I can jumble the characters of the plain text so that it may not be readable during the communication. I just going to shuffle or jumble the letters of the cipher text, plain text. That kind of operation will be the transposition. And third one is, why do I simply apply the substitution or transposition? Why not I go for apply both? I do substitution, I do a transposition. I do a substitution and another level of transposition. If I have an interleaved kind of both substitution and transposition, I would call that as a hybrid approach, which is otherwise a product type of encryption. Okay, so what type of operation I'm going to perform inside the encryption will categorize the encryption techniques into substitution techniques, transposition technique, or the product techniques. Okay, and again, I think now we are no learn we have learned about what is a key. That is the additional information that needs to be fed to the encryption method in order to get operated upon the original plain text message to convert it into a cipher text. How many keys you are going to use? With respect to the number of keys we are going to use, one can classify the encryption methods into uh, single key encryption or two key encryption. Let us come to the single key encryption. Single key encryption is, please note down, if you are interested, single key is otherwise called as a symmetric key encryption, or otherwise popularly called as a private key encryption. So what is a single key? What is a private key? What is a symmetric key encryption? All these are referring to the same operation. It means that the key that is used for by the encryption will be the same key used by the decryption. Okay, so the key I'm using to lock my message to secure it will be the same key used to unlock the message to get back the original plain text. Okay, if I use the same key, if the sender and the receiver use the same key, then that will be the single key. Since the same key is used, hence it is a symmetric key. This symmetric key is known only to the sender and then the receiver, not to anyone else. Apart from the sender and the receiver, nobody else knows what is the key being used. So hence it is a private key encryption. Okay. So with respect to the number of keys used, if I use a single key, that will be the uh, single key encryption or the symmetric key encryption. One second. And there is the second option called as a two key encryption. What is a two key encryption? It means that the key I'm using for the encryption will not be the same key used for the decryption.
सुरुवातीचं सरांचं नाव लिहिलं वी आर मराठीच्या जागी फक्त एबी सुरवसे म्हणून एबी सुरवसे
Yes. So if I use one key for encryption, and if it is not the same key I'm going to use for decryption, that will be the number of keys will be two keys. Okay. So I'm not using the same key used for encryption for the decryption. So that is called as two key. Among the since we are using two different keys, this system is referred to as the two key encryption, and since it is opposite to symmetric key encryption, it is called as a asymmetric key encryption. Among these two keys that we use for encryption and then the decryption, one will be the one key will be kept secret, and the other key will be kept is made public, that is, it is known to everyone else, it's made known to everyone else, and that is why this kind of encryption is the public key encryption. So public key encryption, two keys will be used, one will be used for encryption, another one will be used for decryption, and among these two keys, one may be made public, that is, it is known to everyone else, and one may be kept secret. Okay, and hence this encryption technique is the public key encryption. Okay, and the third kind of classification we have with the encryption technique is how we are going to treat the input, whether I'm going to divide the message into equal sized blocks or segments and apply the encryption, thereby generating a block of cipher text, then that will be a block cipher. Okay, or otherwise I'm converting the message into a stream of binary bits, and apply the encryption. It's like the stream goes into the encryption procedure and keep on generating a stream of output as a cipher bits, then that will be a stream cipher. Okay, so divide the message into equal sized blocks, apply the encryption method over each block, thereby generating a single block of cipher text. Once that block's processing is over, take the another next subsequent block, apply the encryption, and you generate another block of cipher text, that is the block cipher. Or otherwise we convert the message into a stream of bits, apply the encryption, thereby generating bits of cipher text. So that way we categorize the message into, I mean, the encryption techniques into block and then the stream cipher. Yes, someone has as someone mentioned in the chat, it is a kind of encoding and decoding. Okay, but this encoding with the encoding may not the actual encoding techniques we refer to in different other fields of engineering may not require any additional information to operate that encoding procedure on the message, but this encoding technique, which we call by the name encryption, requires an additional information key. Without the key, the encryption and decryption will never work. Okay, so that is a kind of difference between the encoding and then the encryption. It's a kind of transformation. Encoding is also a transformation, encryption is also a transformation, but encoding accepts the message alone and applies some procedure over it, or image alone and applies some procedure over it and transforms it. But this encryption accepts them, not only accepts the message but also needs some additional information in order to get operated over the message. Okay, that is why this is encryption, and that is the difference between encryption and then the encoding. So I can do substitution, the with respect to the type of operations I do within the encryption, my algorithm, my procedure, security transformation may be a substitution cipher, or it may be a transposition cipher, or it may be a product cipher. With respect to the number of keys, I'm classifying the encryption techniques into symmetric encryption or asymmetric encryption, private encryption or public key encryption, one key encryption or two key encryption. All these are one and the same: single symmetric private and two asymmetric and public key encryption techniques. And with respect to how I'm going to treat the input message in terms of blocks, it will be called as a block cipher. In terms of stream, it will be called as a stream cipher. So now we are going to start with the single key asymmetric key or private key encryption. So that is our next topic to discuss here. So what is a symmetric? This is the most conventional encryption that has come into practice since 1970s. Okay, and also most widely used kind of a security mechanism, security transformation technique among the two techniques. What are the two techniques we are mentioning here? One is a symmetric, another one is a asymmetric, or otherwise private key or public key encryption. So that is a symmetric encryption. Okay, so the symmetric encryption accepts accepts the plain text message. This is the plain text message, and that message goes into the encryption procedure. The encryption procedure uses the key. Uses the key. Remember, symmetric cipher uses the same key to do the encryption and then the decryption. So, with the help of the key, the encryption algorithm will be operated upon, will be applied upon the plain text so as to generate the cipher text. So, the generated cipher text will be sent to the other end, undergoes the reverse of the encryption called as the decryption, and the decryption uses the same key that the encryption has used by the sender's end. So, by doing the reverse transformation by the name of the decryption, we can get back the plain text at the recipient end. So this is how the symmetric key encryption works. Okay. So having seen the cryptographic techniques, as we have as I mentioned earlier, that the cryptographic techniques are productive, I mean constructive kind of work. What is the constructive part here? We are securing the message. Our basic intention or objective is to secure the message. That is why we are going for cryptographic techniques. And we have seen several types, like what type of technique one can go for with respect to the underlying application that we are working with. And as we are securing by the time we are securing the message, there may be someone waiting for us to communicate to the other end, so that they can tap the message in the middle of the communication and get to do whatever they want to do in order to confuse both the ends. So as to disrupt the communication between the two end parties. That is called as a cryptanalysis. Okay, what is cryptanalysis? Without the knowledge of the key, he wants to break the attacker or the hacker wants to break the cipher text to bring back the plain text. Okay, so just assume I'm communicating a secured message to the other end. Now the attacker in the middle taps the communication, gets the cipher text, do something over the cipher text by the name called as a cryptanalysis, and somehow he gets the plain text by some method. He may have some partial knowledge about what might have happened at the sender's side in order to do this transformation. He somehow breaks down the cipher text and gets a plain text. Okay, so that point of time, that is a kind of success that is achieved by the cryptanalyst that point of time. But that to achieve that success, for the next message he has to do the same set of operations to break by breaking down the cipher to get the plain text back. Okay, so if it is possible by the attacker or by the hacker or the cryptanalyst we are talking about here, is able to by some means, that cryptanalyst is able to get what is the key being used to do the transformation. And please remember, the algorithms, all the security algorithms, the cryptographic techniques and algorithms are available in public in internet. It is not it is not a secret information. The only thing that is secret is the key used for the transformation and the message that is to be transmitted to be secured or sent in a secret manner. Okay, so the algorithm used is never kept secret. It is available. You just go and type AES, advanced encryption standard, DES, data encryption standard. Such algorithms like RSA, reverse Summer, and Adelman is a kind of public key algorithm, Diffie-Hellman, or ECC, elliptic curve cryptographic algorithm, or so there are so many algorithms of symmetric and asymmetric algorithms that have been developed by the people earlier, by the developers earlier. These algorithms are never kept secret. They are available in public. They, whenever you want to know what is the working of these algorithms, just go and just type these names. That particular standard will be resulted in your Google page, and you can get to learn what are the steps involved in the transformation. Okay, so the algorithm is public. The only thing that is kept secret is the key being used. If the cryptanalyst is able to retrieve what is the key being used, he can easily use that key and perform a decryption over the tapped message and gets the plain text back. So that is the intention of the cryptanalyst, not achieving a success for a particular crypt analyzing operation that gives him the communication only once, the plain text only once. If he is able to get back, if he is able to break down what is the key being used, he can use the same key for the future communications, and he can listen to what are being communicated between the sender and the receiver, since he owns a key. That if that is the key to be used for all the future communications. Okay, so that may be the actual intention of the sender and then the receiver, getting the key, what is the key being used. So there are two different possible crypt analysis. One is crypt analysis itself, cryptanalytic attack itself. Another one is the brute force attack. The brute force attack, I do not know the length of the key, the size of the key. I don't know anything else. I simply start with the 1 bit key, or a 2 bit key. We know how many possible combinations that can be arrived at a 2 bit information. I can have 2 power 2 combinations. Okay, 00, 01, 10, and 11. Okay, so I have 4 combinations. If my key size is 3 bits, length is 3 bits, it is how many combinations I can arrive with? It is 2 power 3 combinations. Okay, so totally 8 combinations. I will what I would do as a brute force attacker, I take the first combination, try to decrypt the received message. I'm an attacker. I have tapped the communication in the middle of the sender and then the receiver. I have the ciphertext with me, and I have all possible key combinations with me. Okay, 001, 010, and in the same way I have all the key combinations. I take the first key combination, have the ciphertext with me, and I know the algorithm that is being used to do the transformation. I supply the first key combination to the received ciphertext and try whether I'm getting I attempt whether I'm getting the actual plain text. Okay, if that attempt fails, I'm not getting the readable plain text during by this possible operation, I take the next key combination and try it with the ciphertext and apply the algorithm. If that fails again, I try with other combination, again other combination, until I earn a success. Obviously, if there are 3 bits, one among the 2 power 3 combinations will definitely break down the ciphertext and get you back the plain text. Okay, so without knowing the basic knowledge about what is the size of the key or something about the key, if you keep on trying with all possible key combinations, with the 2 bit combination, 3 bit combination, 4 bit combination, 5 bit, 6 bit, as long as your computational resource supports you, if you keep on trying with all possible key combinations, your intention is to try get back the plain text. And if you're getting it back, that kind of attack is a brute force attack. Okay, so there is this another attack. As we have seen, brute force does not, the person who is doing the brute force attack will do not have any information about the key being used or anything about the plain text. Okay, if there is some partial information I happen to gain, I may be a disgruntled employee, I may be a recently penalized employee, I may be a recently fired employee from that organization. I may know what may be the plain text, what I may not know, what is the key being used. So what I would say, I would do, I know for this plain text, this is a ciphertext. Since I have partial knowledge, my working knowledge, since I had been an employee, I know what might be communicated. Okay, but I don't know what is now what is the message that is now communicated, or what is the message being transferred that point of time. But I knew for this plain text, this is what the ciphertext is. Okay, so with this combination, if I work with some kind of statistical information, and with this partial information, if I try to break down the cipher to get back the plain text, then that is the cryptanalytic attack. Okay, so there are two different attacks. One is the cryptanalytic and the brute force attack. So these are all the several other attacks. I'm just skipping it. Ciphertext only, known plain text, chosen ciphertext, and chosen text. You please, if this is shared with you, please go through it. These are different possible cryptanalytic attacks we have. Okay, so when you the what are the possible characteristics owned by a secured message? So you have the GPUs, you have the TPUs. Heard about the graphical processing unit, tensor processing unit, GPU, TPU, CPU. You have whatever advanced configuration system that comes this week, that has been introduced this week. You have that system, assume. You have that kind of capability in terms of computational power and computational speed, and then the resources that are needed to work with the data. Even with all these computational highly advanced configuration systems with you, if you are not able to break down the cipher text to bring back the cipher, then we can call that kind of cipher as unconditionally secure. Whatever time you put in, whatever effort you put in, whatever resource you use, even then you are not able to recover the plain text. So I would say now that message is a unconditionally secure message. And there is this computationally secure message. This is a kind of interesting one. This computationally secured message is, you keep on taking your time, day 1, day 2, day 3, and so on, and using all possible machine configurations, high-end systems to break down the cipher. On the 10th day, you are breaking the cipher and you're getting the plain text back. But the message, the validity of the message might have expired after the first 24 hours being transmitted towards the receiver. After after the message validity is expired and exhausted, and you have broken down the cipher to into the plain text, which is of no use. Even if you have break it after the validity expires, it is of no use. There is a single usually used example in this part of in this contest. Attack at 10 a.m. tomorrow is a kind of message uh, um, usually used to make understand people about the computational secure cipher. Attack at 10 a.m. tomorrow, this is a message sent by the from the base to the war front, to the people at the war front. Not only this message is sent, it also comes with the timestamp by what time it has been sent, and who has been sent the message. And attack at 10 a.m. tomorrow on 29/12/2020. If someone captures this message and replays it again and again, someone receives the message on 30th. On 30th, the receiver receives the message on 30th. But what about the message? What does the message say? It says that perform an attack at 10 a.m. on 29th December. But you are receiving your message on 30th, since because someone in the middle has captured the message and have not transmitted the message further towards the receiver. Okay. So, or otherwise, someone wants to tap the message and change the content of the message. And this kind of thing, if it happens even after the expiry of the message is over, then that is called as computationally secure message. Your message is computationally secure. It is breakable, but not within the stipulated time. Okay. Even if you get a message, it may not be of use to you. It may of no use to you. If you get a message on the 10th day whose validity expired in the first 24 hours since it was sent. Okay. So such security is computationally secure. Okay. So let us come to the first substitution technique. It's a very simple technique. We are going to see few of the substitution techniques and few of the transposition techniques. If time permits, shall also go into the public key encryption techniques. Okay. So substitution technique, I'm going to say what is what. This is what the first technique used in the history of cryptographic techniques, since named after the developer, the Caesar. He sent messages using this technique to the people at the war front. If someone gets the message in the middle, that particular someone in the middle might not have broken the cipher to read the message what is being transmitted. So what is the Caesar cipher? It is very simple. This cipher can work upon the English plain text. Take one letter of the plain text, you add some constant value. We know we have 26 characters in the alphabet. If I add a constant value to each of the letter of the plain text, and I will get that particular number. I mean, if A is the letter being communicated, is one among the letter in the message being communicated, I am going to add a constant value, say 3. What is A plus 3? It is B, C, and D. That is, take A is a substitution technique where we are going to take one letter at a time or few letters at a time and replace it with another letter or another set of few letters. Here in CC cipher, I'm taking one letter at a time, add a constant value to it. That is a kind of displacement. If I add 3 to it, I'll take the third letter down the alphabetical order in the alphabetical stream and take that third letter will serve as the displacement letter or the replacement letter or the substitution letter. Okay, so look at this one. Meet me after the toga party is the message, and you are getting this kind of meet me after toga party is the plain text message. If we apply the Caesar cipher, can you tell me by what displacement we have got this particular plain text message? This is for M it is P, for E it is H, for E it is H. M N O P. Again, it means that the displacement is 3. The displacement is 3. If I apply 3 over all these letters, plus 3, plus 3, plus 3, I may get the third letter down the alphabetical order. What if I get to the end of the alphabetical order? Say Y. Do I have any letter beyond Z to add to get what is the third letter down the alphabetical order? No, I don't have any letter beyond Z. So I will come back in a circular manner. I'll come back in a circular manner. Okay, so this Y will be replaced by B. It means that Z, A and B. The third letter in a circular manner is B. Okay. So that is how the Caesar cipher works. If this is an encryption that gets the cipher test, how the decryption works? You just take the letter of this will be received by the receiver, right? So he takes each letter and takes the third letter in the reverse direction of the alphabetical order. So that will be P minus 3. If I add M plus 3 to get the cipher test, the receiver will do the reverse operation by the name of decryption by reducing the number 3 from the letters received. So that is what is a Caesar cipher. Okay. So and next one is, this is an example you can see here. If it is a very simple encryption technique that can be easily cracked down to get the plain text. Since we have only 26 possible key combinations we can work with. The key is the displacement we are adding to the plain test. I add 1, I'll check whether I'm getting a readable plain text or not. I add 2, I am checking whether I'm getting a readable plain text or not. The first 2 attempts are failure. I add 3 and I'm seeing that meet me after toga, but it's a kind of a readable message I'm getting. So I can try with all possible key combination 1 to 26. One line is not visible here in this picture. 1 to all possible 26 key combination. Obviously, I will end up in success with one possible key combination that will give me the plain text back. That is how secure is the Caesar cipher. It is no longer a good cipher to talk about. Okay, if you want, you can play with this particular cipher and find out at the end of this class what is the actual plain text behind this cipher. Okay, please note it down if you want, if you're interested. The next cipher is since Caesar cipher is no longer a good cipher, people started thinking about what kind of operation that can be further done so that Caesar cipher can be further improved. Okay, so why should I add a constant displacement to all the characters as I have done in the Caesar cipher? Why not I map each and every character of the plain text to a letter in the alphabetical order in some random manner? That is, A, when wherever you have A, you'll have to replace all the A's with capital D. Wherever you have Z, you will have to replace the occurrences of Z in the message with the capital N. That way you can see if you wish to replace letters as the plain text message, I is replaced by W. So wherever you have an I, it will always be replaced by the W. So this is a kind of cipher which takes one letter of the plain text and replace it with a fixed character of the cipher text. That is called the monoalphabetic substitution cipher. Still a substitution cipher, but this is also no longer a secure cipher, I would say. If you have taken notes of anything that is happening in the day, or whatever notebook you have with you, just turn over the pages, look for a particular line that has that where we have written something from left to right end of the page. Okay, take that particular line, just look at that line and count what is the most frequently occurring character in the line you have written. take that, okay, and count what is the second most frequently occurring character in the message that you have written in the line text. In the text you have written, the same way you keep on taking the statistics about what is the highest frequently occurring, the first or most frequently occurring letter, and second most frequently occurring letter, third most frequently occurring letter. If you keep on taking this, you can come up with all the letters and the frequency. I has occurred for 10 times, H has occurred for 4 times, A has occurred for 20 times, like that. For each and every letter, you can come up with the statistics. This kind of information can be used by the cryptanalyst who wants to attack the cipher, monoalphabetic cipher. He takes the cipher text from the communication channel. He observes the, taps the cipher text from the communication channel and takes the statistics like this. Okay, he comes to know this Z has occurred some number of 12 times. Okay, and this particular Y has occurred or O has occurred some number of 8 times, and he takes a statistical table like that from the from the captured message. And look at that, English is a language that exhibits this kind of histogram. If you look at the slide, there is a histogram available for it tells us in any English language text that we are using, the most often the most frequently occurring letter will be E. The highest occurring frequently occurring letter will be E with the frequency 12.7, and the second highest frequently occurring letter will be T with 9.056. And the same way there is this A that comes in the third place, and then if you keep on looking at that histogram, you can see the number of times, the frequency of occurrences, how frequently these characters can occur in the English text. Okay, so with this graph or with this information, the cryptanalyst who captured has also derived with some information from the captured cipher test. He takes the most frequently occurring character in the cipher test and compare that with this particular histogram. Okay, so now he tries to replace the most frequently occurring character, that is the Z. All the Z he wants to replace with E here. Okay, in the same way, he finds that Y is the second most frequently occurring character in the cipher test. He tries to replace all the Y's with the letter A. The same way, he keep on filling in, replacing all the letters in the as a part of cryptanalysis. If you are given with a partially filled message with say like T dash P, T dash E, you can easily identify those 3 letter words or the 2 letter words in the English: off, it, on. Those are the 2 letter most frequently used 2 letter words. Is, and those are in that, with the help of that knowledge, one can easily fill in the rest of the characters in the message. T dash P will be tap or tip, or T dash E will be the. That kind of knowledge we have, and we can easily fill in the rest of the characters in the text. And the cipher cryptanalyst can easily break down the monoalphabetic substitution cipher. Okay, so again, that is also not a viable solution to secure ours. Okay, and there comes the playfair cipher. Having seen the security of how strength the Caesar cipher and the monoalphabetic substitution cipher, people developed another cipher called the playfair, named after the person Playfair. But it is developed by Charles Wheatstone in the year 1854, which was used in World War One. Okay, so this is a kind, as the name suggests, this is a kind of easiest one. Playfair cipher, the key that we are going to use in the encryption will be placed in the 5 by 5 matrix. We know that the nearest square matrix that can hold all the 26 characters in the alphabet will be a 5 by 5 matrix if we are able to have 2 letters in a single cell. Okay, so I'm going to, if monarchy is the key I'm going to use for the encryption method, I'm just going to fill in the letters of the monarchy in this table, in this matrix, and MONARCHY, none of the letters in the monarchy are repeating. I need to make sure that no letters are repeating in this matrix called as a Playfair matrix. So I first fill in the letters of the key, and after that the rest of the places are filled with the rest of the letters of the alphabet. Okay, so A is already present, so I'm skipped, so I'm using B here. C is already present, I'm skipping that, and D, E, F, G, H is already present, skip it. So as I said earlier, you can have have two characters in one single cell so as to accommodate all the 26 characters here. So I'm going to have I and J here, and then in the same way the rest of the alphabets will be filled in the matrix. This is called the Playfair matrix. With reference to this matrix, I'm going to substitute one letter with another letter of the plain text. Okay, so now there are some rules I'm going to follow. So this is if my word is assume college is something like security is the message I'm transmitting. The message itself is security. So I have to divide the message into diagrams. Diagram is a two-letter word. So take the first diagram S and E. Just check where is S here. Yes, in this particular table matrix, S is here. Where is E? E is here. So take the row of S and the column of E. What is the letter at the intersection? L is at the column of is at the intersection of E and S. If you draw a triangle, rectangle between E and S, you will end up with L is one corner and I and J at the another corner. Okay, so S will be replaced by L and E will be replaced by I. In the same way, I found the replacement characters from the table. What is the next two diagrams in the cipher? It is C and U. So I take C, and where is U? Both lie on the same column. If they are two letters of the plain text lie on the same column, I go for the letter beneath it. So C will be replaced by E, and U there is no letter beneath it. So I will come back in a circular fashion, use M as a substitution letter for U. Okay, and again R and I is the next character. So draw a R and I come in two different rows and columns. So draw a rectangle. The corners of the rectangle will be the replacement characters for R and I. If two letters fall on the same row, the letter to the right will be the replacement character. So again, this is how the play for cipher works. Again, this is also not preventing the cipher test from exhibiting the English language characters we have seen earlier. So people try to develop another method called as a hill cipher, which uses the polynomial kind of expressions to overcome the drawbacks that we have seen with the previous ciphers. Okay, that is a hill cipher which uses the matrix multiplication. You convert all the plain text into the matrix, convert the key information into a matrix, perform a matrix multiplication, and since there is only 26 characters with us, there is this particular operation is performed. Mod 26 will allow you to work in a circular fashion within the 26 characters. Okay, so perform matrix multiplication over the plain text and the key and apply the mod 26. So how does this will be the encryption procedure. How does the receiver perform the decryption? It performs the reverse of this encryption, right? So it receives a ciphertext C and it has to bring back P out of it. Okay, so it applies for K, that is a key matrix used in the sender side, for which the receiver will perform a inverse and identifies computes the inverse of the key matrix and multiplies the key matrix with the ciphertext and applies the mod to bring back the plain text. So this is how the hill cipher works. Okay, and there is another kind of cipher called as a polyalphabetic substitution cipher. So far we have seen for any character there will be always a fixed character as a substitution character. Why should I use the same character for the next occurrence and the next occurrence of the plain text character? Why should not I use I go for the first occurrence of A, let me use Y as a replacement letter. For the second occurrence of A, let me use Z as a replacement letter. So in that way I can use any letter for each and every occurrence of the same character in the plain text. Such a cipher is polyalphabetical substitution cipher, which is the one particular polyalphabetic substitution cipher is Wigner cipher. This Wigner cipher, look at this table. This is called as a Wigner table. You can see the letters are all the column heading and some letters are on the row heading. Okay, so the plain text characters can be placed on the column and the key letters can be placed on the row. If my word is security, if my word is security, then I will take S from the column and E from the row. So what is the intersection of the S row, S column and E row will be the uh, replacement character. Okay, so this particular table, you can see the first row starts with A to Z, second row starts with B to ZA, and third row starts with Z to and ends with B. Likewise, the last row starts with Z to Y. Okay, so this table will serve as a reference table. Okay, from this table I take one letter of the plain text as the column heading, and take a letter of the key from the row heading, I mean as a row index, and the letter at the intersection of the column and the row will be the replacement letter. That is a Wigner cipher. Okay, so there is this stream cipher we have seen, right? That converts the message into a stream of information and applies the encryption procedure. One such cipher is Vernam cipher. The Vernam cipher generates a stream of bits and accepts the stream of plain text, and it applies a simple XOR operation over the plain text information and then the key bits. Okay, so that is the Vernam cipher, and there is this one-time pad. As the name suggests, we have seen the intention of the cryptanalyst will not getting success at a single attack. He might want to know what is the key being used so as to break the future ciphers that are being communicated. So that is his intention. That will be his intention. So if his intention is to break the cipher to bring the key, and he thinks that the key will be the same in the future communication. So in order to handle that kind of problem, people started using one time pad, that is use a key only once and discard it. Okay, so that kind of using the key only once and discarding it will be the one time pad. Okay, but it is very difficult to use in practical practice. That is, you have to generate a key whenever you have a new information to be communicated. You have to communicate the same key with the other end in a secret manner. So there comes the drawback of one time pad. Okay, that's all about the substitution ciphers. There is this transposition cipher that we have seen earlier, that by simply reassembling or changing the positions of the character, transposition, changing the position or jumbling or shuffling the characters of the plain text, so that that helps us to convert the readable plain text into unreadable cipher text. So one best example will be rail fence. So just look at this: meet me after the toga party is the message to be transmitted. If I apply the rail fence cipher over it, you remember how a rail fence look around the railway station and all. There will be a picketed fence, like I mean a white fence in this manner, so V shape edges over it, right? So the wooden lodges will be placed one after another. The edges, the topmost edges will be look like some www. So I'm going to write my message in this form: meet me after toga party. Write one letter at the first row, second letter diagonally, and third letter again to the first row, and then again diagonally. If we keep on write the letters in this manner, in a W like manner, which resembles the rail fence, then take the letters of the first row, MEN, and after writing the letters of the first row, take the letters of the second row. So thereby, this I am using as a means to jumbling the characters. Okay, so thereby generating the cipher text. So this is one kind of transposition cipher. There is another transposition cipher called the row transposition cipher. So take the example: attack postpone until 2 a.m. tomorrow, until 2 a.m., and key will be like this one, some numerical key string. I'm writing the letters of the message to be secured in a matrix format. Write the key over the matrix and take the letters with the column with the number one. So what is the column with the number one? TTNA, that has the column ID number one. Follow that will be the first few letters of the ciphertext. And what is the and that will be followed by the column with the number two. So APTM. So that will be the next few letters of the ciphertext. So that way I'm simply using the key information as a kind of a reference string. With respect to that reference string, I am jumbling the letters of the plain text, taking them from the matrix and converting them into unreadable cipher text. So this is a row transposition cipher, and there is this product that combines both substitution and then the transposition techniques. And there is another kind of vertical that secures the message being transmitted. The cryptography, it shows the presence of the message to the cryptanalyzer or the attacker, wherein there is a steganographic field where If you all remember, there is this simple thing we play when we are young, that we write something on a white paper using a soap or a detergent kind of thing, which may not be visible to the naked eye. When you soak that paper, immerse that paper in a in water, the thing we have written in the soap, using the soap, will be visible, will be made visible when the same paper is soaked into the water, rinsed in the water. So thereby, if we hide the presence of the message in order to secure, that kind of technique will be the steganographic techniques. Okay, it's kind of opposite to cryptographic techniques. Cryptographic technique reveals the presence of the message being communicated, though it is not readable. But the steganography, both of these techniques, steganography and cryptography, the intention is same, to secure the message. One reveals the presence of the message, but it is not readable. The other one does not reveal the message is present at all during the communication. The message may be hidden behind an image, or in the audio file, or in an image file, or in a video file, and sent to the other end. The other end, knowing this particular message has undergone a steganographic technique, it tries to retrieve the message from the video file or the audio file or from the image file. So that is the steganography. Okay, so the next kind of encryption is the public key encryption. The public, with this I finish this session. The public key encryption is, as we have seen, one key is used for encryption, another key will be used for the decryption. Each and every person owns can I continue for another 5 to 10 minutes?
Yes, yes,
Huh?
yes.
Thank you. Okay, so the public key encryption is something where we use one key for encryption, another key for the decryption. One among the key will be made public, and one among the key will be kept secret. Okay, that is why it is called as a public key encryption. So we use the public key encryption for two purposes. One is, we have talked about sharing the secret key between the sender and the receiver, and the symmetric key, right? How it can be shared? You can use the public key cryptography to do that key exchange. Okay, and also there is this digital signature. Nowadays we know what is a digital signature. It helps us to claim who is the sender of the message. Okay, and it can be verified. If it is not verified, you need not trust the message you have received. The digital signature verification fails, you need not trust what is being received, what you have received. Okay, so for these two operations, one can use the public key cryptography, which was developed by these two people, Diffie and Hellman, Whitefield Diffie and Martin Hellman, in the Stanford University by the year 1976. Okay, so this is the public key cryptography. It means that each and every end party, there is a sender and there is a receiver, right? Each and every end party owns two keys. One is their own private key, one is their own public key. If each and every one of us will own two keys: my private key and my public key, your private key and your public key, someone else private key and someone else's public key. So each and every person in the network has two keys. Okay, so one key I keep it secret, and the other key I will reveal it to everyone else. See, I am Bhuvana. This is my public key. Make a note of it. Okay, so every one of you will know what is my public key. And the same way, I know your public key also, but I don't know your private key, and you don't know my private key. That is how the public key cryptographic technique works. So let us see a model for public key. Just how we have seen a model for symmetric key, we see a model for the public key. So this is a model for the public key. You can see a ring here. Can you see a ring here? This ring is, if I own a ring, what I might have in that ring? My own private key, my own public key. At the same time, I also know other people's public key. So you can see Bob is this person who owns not only his public key, but also someone by the name Joy's public key, someone by the name Mike's public key, someone by the name Eliza's public key, someone named by the name Ted's public key. So these are all the other people available in the network. So he knows other people's public key also. Does Bob know Joy's private key? No. Does Bob knows Ali's private key? No. So one's private key is private to themselves. Okay. So the plain text here also, the intention is to provide security to the message, but the public key crypto system is prominently designed to provide a specific service called as authentication. It helps us to identify who is the sender of the message or who is the author of the message, sender or the receiver. The identity can be claimed or verified by the public key crypto system. So I am going to apply an encryption procedure on the message before it is transmitted. Can you guess if I use my public key? Uh, the key that is used, I mean the key that is to be used for the decryption will not be the same key used for the decryption. That is understood from the public key cryptographic system. But please also remember, the key that I'm using for encryption, I mean the other key I'm using for the decryption should belong to the same person whose key was used for the encryption. If I use Ali's key for Ali's public key for encryption, the decryption should use the corresponding key of the same person, the other unused key of the same person. If Ali's one key is used for encryption, the same person Ali's other key should be used for the decryption. Okay, so this is Bob, who is the sender, using other person Ali's as a receiver. He knows others Ali's public key, he uses it for encryption, sending it to the other end. This particular encrypted message can only be opened by using the same person Ali's key. What is the only unused key that can be used for the decryption? Public key of Alice has been used. So this N, who is Alice himself, who knows his private key, nobody else knows the private key of this Alice, who uses the private key and do the decryption, does the decryption to get back the plain text. Okay, so this kind of using other N's public key for encryption and receiver's private key for decryption will provide authentication service. Okay, and this can be also used for the confidentiality service. If I use my private key for my private key to do the encryption, whenever the sender uses his own private key for encryption, then that will be equivalent to the digital signature that helps the other end to claim who is the actual sender of the communication. Okay, so these are all the applications of public key encryption. You can use it for providing confidentiality, you can use it to generate digital signature, you can use it for the purpose of exchanging the keys between the sender and then the receiver. And what you're seeing on the slide, or the first column shows the famous public key cryptographic algorithms, RSA, elliptic curve, Diffie-Hellman, and digital signature standard. I have seen, I think, digital signature or PKI, some such things are coming in the forthcoming days of your FDP. I think other experts will be handling those things. So these are all the famous public key cryptographic algorithms. RSA will be used for all the three applications listed, used for secrecy, or used to provide digital signature, used to do the key exchange between the sender and then the receiver. Elliptic key is meant for is also can be used for all the three applications. Diffie-Hellman can only be used for the key exchange, which we need in the symmetric key encryption. Digital signature standard, as the name suggests, it is used for providing the digital signature. Okay, so these are the applications of our famous algorithms of public key cryptography and their applications. Okay, uh, so far we have discussed about the symmetric key techniques and few of the symmetric key algorithms, and asymmetric or public key techniques, and we also seen the applications of public key encryption algorithms. So that's all from my side. I can go further with these things to make you, I mean, to introduce the other things also, but because of the time I'm restricting myself with this one. If you have any questions, I'm ready to take the questions now.
Participants may ask questions. Any questions?
I know, I understand the participants are from different backgrounds. I hope I instilled, I mean, the introductory terms and terminologies about the cryptography, so that it will helpful to understand the other topics like web security and PK and digital signature. These things they rely on what we have discussed in this session, definitely. And I hope these things help you to understand the further advanced titles you're going to have are going to see in the forthcoming days. If there is no question, sir.
Yes, yes. And
Huh?
we are seeing from the chat box that it was very informative. And
Okay.
if there are no questions, I would like to thank Dr. J. Bhavana for giving this nice presentation, giving all the important details related to cryptography and information security. Thank you, madam, once again. Thank you.
Thank
And,
you. Thank you, everyone. Thank you, sir.
and tomorrow we have the morning session at 10 o'clock. We'll wind up for now and then join again at 10 o'clock, maybe 10 minutes before 9:50 tomorrow morning. Thank you.